Let's see, is this on? Okay, hey guys, I'm just gonna do a quick recap of day one of Advent of Code. I've also just made some changes to my camera settings and stuff, so I'm checking that out while I do this. This is not a live solve, I've already solved this. But let's quickly look at the first one here. So basically, it's a problem about a dial on a safe, right? So right away when I read that, I was like, this is probably like some kind of modular arithmetic, modular division type problem. Because when you rotate the dial all the way around, it goes back to zero, right? Goes back, goes back, goes back. And that's a real hint that we want to use a mod. So the key information here, the dial starts at 50, it goes up to 99, and then it goes back to zero. And so for the first part of the problem, we're basically just trying to see how many times after doing this set of operations where I'm turning it left a certain amount, turning it right a certain amount, how many times is it going to be pointing at zero at the end of an operation? One thing that I do remember tripped me up for a second was when you turn left, and this might be mirrored for you, when you turn left, I was assuming left meant like counterclockwise and right meant clockwise, which the way that I'm picturing it, left would mean numbers increasing, but they actually mean left is decreasing, right is increasing. So just make sure you read that carefully, right? So going left from 0 goes all the way around to 99, and going right from 0 goes back to 0. So basically left is negative, right is positive, is what they're saying. So I should have just read that instead of trying to like figure it out by picturing in my mind which way is clockwise and counterclockwise. Anyways, so the code was pretty simple. I set myself up at starting at 50 because that's where we start, and I want to keep track of the count of the number of zeros. I read my input, split it on new lines, chop off the last empty line, because there's a long input, empty line at the bottom. So I get my line and I parse it. First I'm looking at if it starts with an L or an R, because like I said, L is negative. So if it's an L, I'm going to make it negative. If it's R, I can just assume it's positive, don't have to do anything. And then I parse the rest of the line, which is everything except for the first character. Right, because the first character is the direction, and then the rest is whatever. The rest of the thing. Also, you'll notice some of them can be really big. Like this one is 693, that'll come in for part 2. But for part 1, we don't really care about that. So basically all I do is I change the number, either positive or negative, depending on which direction it is. I take the mod of it. I do the number mod 100 because that's going to basically wrap it back around to 0. And then if it is equal to 0 at the end of this whole operation, I increase my count. If we run it, boom, there's the answer. That was my answer. One thing that you might notice is that I'm pretty sure that this operation can be negative in Python, which is not true of every language. Let me see if I can find an example. Oh, is that not true? I thought there was something that was causing that. Let me do it right here. -3%, 5. 3%, -5. Oh yeah, see, you can get a negative answer sometimes if the denominator is negative. I'm getting a call from an unknown number, ignore that. Okay, so that was pretty simple. We're gonna look at part 2, and I could actually make a significant improvement here, and maybe we will do that live on the phone. But for my initial solve on the day, so for part 2, the problem is similar to before, but instead of landing on 0, it's basically any time you pass the number 0, you want to increase your count, right? So for the example, you start at 50, you point all the way around past 0 and land on 82, but we still want to count that 0 as one that we've passed. There's also this interesting tip at the bottom that if you have a single instruction like rotate right 1000 clicks, then you're actually going to pass 0 multiple times. So in this place, you're going to go 10 times around as you're doing 1000, 100, 200, 300, 400, 500, 600, 700, 800, 900, 1000. Right, so that's something to watch out for. So to make it simple cognitively, what I did was I just simulated one number at a time. So similar setup to the first part. I'm getting my number, getting my line, starting at 50, and then I'm basically setting my direction to either 1 or -1, depending on the L or R. And then I'm going to iterate one by one for the whole direction. So if my instruction is L68, I'm going to go one by one 68 times. I'm going to move my start by 1 or by -1, depending on my thing. And I'm going to take the mod so that I wrap around. And if I hit 0 at any point, I'm just going to increase the count. So basically, I'm simulating click by click individually the exact instructions. And you'll see this totally works. Oh, I thought it was slower. Maybe it was slower yesterday because I was printing it or something. I thought this was slow because it does simulate a large amount of numbers, right? Right, so when we do a big instruction like 732, we're doing 732 operations. Now, I'm pretty sure you could cut that way down by doing some math. But since it's actually that fast, I'm not even tripping on it. I don't know why I thought it was so much slower. I think when I was doing it, I had something like this in there just to see where it was at, and maybe all the printing slows it down, so I was like, oh, maybe this is a slow program or something. So yeah, that's that. I think if we were to do this in a different way, then maybe we can just take a moment to do it because it could be fun. I think we would first want to figure out how many full rotations we've done. So I'd say like full rotations is number divided by 100. Integer divided by 100, because that means we've gone completely around from where we started. Is this gonna be weird if you start from 0? Because that's gonna be one more. I'll figure out 0 in a second. And then maybe we want to see what's the remainder is going to be percent 100. So let's think. If we're going left, then we're decreasing. So I'd say if direction is L and remainder is greater than that's going to be 1. Else if I'm going right, I'm increasing. If num plus remainder is greater than or equal to 100. Something like that. Say start equals start plus 9 times num. Let's see if that still gives me the same answer. No, it did not give me the same answer, so I've made a mistake somewhere. I bet that it has to do with it being exactly 0. Let's see what that does for me. No, that's still not it. Okay. Let's try and think. Maybe we can use our basic example as a debugger. see what that does for me. Oh, I think I might have already seen it. I'm looking at something more like that. No, still not right. Okay, let's see. Okay, so we start at 50, go left 68, full rotation, count 0. We did rotate past 0. Now we're at 82. Line 30. Full rotation, count 0, remainder 30. Rotated past 0 again. We did not rotate past 0. Start. Is that right? That's closer. No. Now we're lost in the weeds, but that's fine. Maybe I can cut this from the video. Let's add a break in there. Okay. So we start at 50, rotate past 0, and at 82. Start at 80, go left, don't pass anything, and at 52. Well, that's interesting. Rotated R48 to point at 0. So my remainder is 48. That was num plus remainder. Not 100. Oh, because it's start plus remainder. Okay. Okay, we're starting to crack the code. Okay, rotated past 0. Rotated past 0. Now for this one, current 0, line 5. Remainder is 5. I need to say I'm just going to say that for now. You start at 0, you're always going to pass it. Okay, so that is giving me the correct answer of 6. Let's throw this in, see if that gives us 10. Okay. So let's try the real input finally. It's gonna print shitload. Let's get rid of some of these. And we did get the right answer, I'm pretty sure, yeah. So let's go ahead and get rid of all these. Oops, what happened here? Okay, so we fixed it up so that we're no longer simulating every single click. We are now calculating the whole thing at once using this division and this remainder. It got a little messier. One little kind of hacky line is this: if start not equal to 0. Only for going left, because we're kind of seeing if we've gone past 0. But if we start at 0, we've always gone past 0, because what we really should be thinking is we're starting at 100 in that case, but we'll never be able to go past 100 in our remainder because our remainder is percent 100. So I just threw in this little thing here. Okay, so for our updated code, we can actually take out this exactly 0. Crap, that was just for testing. So we're getting our direction. We're parsing the thing. First thing we do is calculate the number of full rotations that happen by using integer division. So this is for lines where we have over 100 turns to do in a single line. Like this one, 951. That means we're going all the way around 9 times because 100 is a full rotation. So for each one of those full rotations, no matter where we start, we have to go past 0 as we do a full rotation. So that's simple to calculate. Then with just the remainder, we're trying to figure out if from where we've started, if we are going to pass 0 one more time. So if we're going to the left, basically if our remainder is bigger than the number that we've started at, that's when we're going to pass 0, right? If I start at 32 and I go to the left by 34, then I'm going to go all the way down to 0 and then 2 more. So I'm going to pass 0 one time. If we're going right, we're basically going the other way and seeing if we pass 100, which is where 0 would be. So if I start at 99 and I go 2 clicks to the right, I'm going 100, which is 0, increasing my count, and then going on to 101. I did already talk about this, but if I start at 0 and I'm going to the left, then based on this whatever, I'm always going to be passing 0, but that's not true because I already counted that when I landed on 0. So I have to get this little start not equal to 0 to solve that solution. For the right side, I don't have to matter. I don't care about that because I'm not comparing with 0, I'm comparing with 100. So if I start at 0, I'm never going to make it to 100 with my remainder because my remainder is percent 100. So I just don't have to worry about it going that direction. So we've made a sort of a micro optimization. Before I had to do, you know, a number of operations for each line. Like for the first line, I had to do 29 operations. For the second line, I had to do 49 operations. Third, I had to do 41. So before, my time complexity was basically like the sum of all of these numbers, which are for the most part 1 to 2 digit numbers and occasional 3 digit numbers. I don't think there's anything larger than 3 digits, just at scanning this visually. With the optimization, we're basically just doing a fixed number of operations, like 1, 2, 3-ish operations per line. So instead of doing 29 operations for this line and 49 operations for this line, I'm doing like 3 for this line, 3 for this line, 3 for this line, 3 for this line. So the reason I'm calling that a micro optimization is because these numbers aren't that big. So if we say n is the number of lines for my unoptimized version, it's basically, my time complexity would be n times 999, if that's the biggest possible number, because we're only going up to 3-digit numbers. For my second operation, it'd be more like n times 3, n times 5, whatever. But as you might know from doing big O calculations in the past, n times 9 is the same as 999, n times 5 we could also write as 5n, but we actually tend to simplify these both to O of n, because the 999 is not growing with n, that's a fixed number. So even if I added more lines, I'm not getting more than 999. And same for the 5 or 3 or whatever. So these actually have the same time complexity, even if we made some kind of optimization there. Anyways, I mostly went live here just to test my video. So if you watched it and watched my annoying debugging, thanks for that.